So now let's start with circular motion. That is what we are talking about is uniform circular motion. Okay. Now see, think of certain examples of circular motion. Like for example, let's say I tie a stone to the string and they start whirling. Okay. So as I'm whirling that, so the motion is a circular motion, right? Now see, not only that, there are lots and lots of examples what you can give. So that is one. Or earth is revolving around the sun. That's also circular motion, right? Or electrons revolving around the atom, circular motion. So you can give a lot of examples for circular motion. Okay? But here, what we are talking about is uniform circular motion, correct? See, when we talk about uniform circular motion, so the acceleration remains the same. That's the whole point. Alright? See, now when we talk about the acceleration, the speed or velocity, whatever it is, the velocity, all these things, one very important concept about uniform circular motion is the velocity remains the same, whereas the direction changes each and every point of that circular path. Because see, circle, if you have a circle, so once it moves like this, see, that very moment it will change the direction, correct? It will change like this, it will change like this. So every point on the circumference, the direction of the particle changes, whereas the velocity remains the same. Okay? Now, last few chapters, whatever you have learned, like kinematics, Newton's law and all these things, there we talked about just linear velocity, correct? So linear velocity as it was moving, so the direction is the same, the velocity, all these things, blah blah blah, you guys learned about it. But in this case, one very important point is linear velocity is not coming into picture. Okay, so what we say is circular velocity, or we actually don't call it as circular, we call it as angular velocity. Okay, so angular velocity is given by omega. Okay, angular velocity is omega. Now, there is a relation between the linear velocity and the angular velocity. That is, V is equal to R omega. Okay, so V is equal to R omega. Now, this is the relation between linear and angular velocity. Alright, see, now coming to force. Alright, so coming to force. Now, force is equal to m into a, right, Newton's law. Now, what is acceleration in such cases? See, acceleration is nothing but V square by R, we call it. Okay, V square by R. So, we get the force F is equal to mv square by R. Now, this particular term is what we call as centripetal force. I know that you guys have heard about centripetal force, and I'm sure that you guys know what is centripetal. Let me just just review and brush up few things on centripetal force. See, centripetal force is a force which acts towards the center of an object. For example, see like this. So you have a circular path. For the center of the object, the force, it's like it's pulling, the center is pulling the object inside. Okay, whereas the object says, no, I don't want to come near you. I'm staying in the circumference itself. So basically the force which pulls towards the center, that is what we call as the centripetal force. Correct? So that was centripetal. Now, whenever there is a circular motion, two forces act on the body. Okay, one is the centripetal force, one more is the velocity with which it's going. Alright, so two forces acting on it. So the resultant is how it moves. So that resultant forms a circular path. Understood, right? So this is basically centripetal force. Now, centripetal force is the reason why objects travel in circular motion. See, for example, so you see, I gave you an example of a stone tied to a string, right? So as you keep moving, so it forms a circular path. Correct? Now, you're actually holding it, actually you're pulling the stone towards the center, but the stone is moving in like this direction. Right? So what happens? It moves in a circular path. Now, imagine you cut the string. What happens? It moves in a straight path. The tangential motion, remember? So, it moves in a straight path. Right? So, no centripetal force is acting on it. So, that's the reason it moves in a straight path. Not only this, Earth revolving around the Sun. So, here, the gravitational force between Sun and Earth, that acts like a centripetal force for the body to revolve around it. See, again centripetal. Or atom and electron example I give. Now between atom and electron, meaning, come on, proton and electron. So proton and electron, the electrostatic force of attraction, that is the reason for the centripetal force. So the electron will start revolving around the proton. Okay, so like this, wherever we have circular motion, there we have centripetal force. Okay, now see, in the next video what you will be learning is very important concept, that is how an object in a circular path, what happens, like banking of roads and what happens when with the level road and all these things you will be learning. Understood?